Hi friends, welcome to this quiz on real numbers. We are going to be discussing some really important questions here and I'm going to make it really easy for you. So stay tuned for the questions in this quiz and be sure to watch the entire quiz. Alright guys, good evening everyone. Hi, I see a lot of folks are out here. Hi Arya, hi Manish Gupta, hi K Gautam, good evening everyone. Sorry if I can't take all of everybody's name here, but welcome to this quiz on real numbers and we are going to be discussing some really important questions on this topic. And guys, before we start, I want to say a big thank you to everybody for all your love and support because we are happy to announce that we've hit 150,000 subscribers. That's right, Manocha Academy is a family of over 150,000 people now. I think it's around 151,000 now. So thanks a lot for your support and it's really great to read everybody's comments. We are really thankful from our side and we hope to bring greater and better content for you. Hi, good evening. And guys, as you know, we have this website manochaacademy.com. I've put the links below. So do check out our courses. We've got these physics courses for CBSE class 10, for class 9 and ICSE class 9. And soon we'll be launching the chemistry and maths courses. And we have big discounts going on. So do check it out. The website is manochaacademy.com. And the best part is you can see these courses on your phone, laptop, tablet, whatever you're comfortable with, because our website works with all devices. And guys, if you haven't subscribed to our YouTube channel, hit the subscribe button right now and do click on the notification bell so that you get notified about our new videos and the live classes that we are having. Hi, good evening. Hi, Abdul. Hi, Garima. Hi, Suman Sahu. Hi, Mukul. So good evening, everyone. And so are you ready for this quiz on real numbers? So let's get started. So here's our first question for you. Which of the following is an irrational number? Is it 22 by 7? Or is it the option B, 3.14159? Or the option C, where 14159 is recurring? Or is it D, pi? So guys, what do you think is the right answer here? So which of the following numbers is irrational? So guys, go ahead and try this. Very good. I see a lot of answers here. So excellent. I want everyone to be involved in the questions and try your best here. So which of the following is an irrational number? Okay. So one thing to understand here, many of you might be thinking that the value of pi is this, right? But note that this is only the approximate value of pi. So 22 by 7 is only the approximate value of pi and we know that it's of the form P by Q. So option A is definitely rational number, right? This is not irrational. Now let's take a look at option B. Okay. So if you take a look at this number, can you see that it's a terminating decimal number, right? So this is a terminating decimal number and so it cannot be irrational because irrational numbers are non-terminating and non-recurring. And this number is a recurring decimal number. So it is non-terminating because it's something of this form, right? 3.14159 and the bar means it's repeated. The pattern gets repeated. Okay, so it's going to be something like this and it goes on forever. But since it is a recurring decimal number, so it is a rational number. So very good. I see a lot of you have got the correct answer. The correct answer is pi. Pi is an irrational number. And pi is defined as the circumference of the circle divided, so the ratio of the circumference of the circle by the diameter. And these values that you use, pi is 3.14 or 22 by 7. Guys, these are only the approximate value of pi. So don't think pi is a rational number. Very good. I see a lot of you got the correct answer. Excellent. Pi is a good example of an irrational number. So that's our right answer. Superb. Now let's take a look at our next question. The number 1 by root 2 is a terminating decimal number Or is it a non-terminating decimal, non-terminating and recurring decimal? Or is it option C, non-terminating and non-recurring? Or is it none of these? So guys, what do you think is the correct answer here? So go ahead and try this question. So 1 by root 2, which one do you think is the right answer here? So very good. I see a lot of you are trying on the chat. Excellent. So think about it. Which option should work out here? So I'm seeing some people are saying A, some are saying D. What do you think is the answer here? So I want all of you to try this question. Some people are saying C. So guys, what do you think is the right answer out here? So go ahead and try that. Okay, so 1 by root 2, and what do you think will be the correct answer for this question? So we know that 1 by root 2, right? So we know that root 2 is it a rational number or it's an irrational number? So root 2 is a square root form. It's known as surds, right? And these are irrational numbers, right? Because they are non-terminating and non-recurring. And when you divide 1, which is a rational number, by root 2, you're still going to get a irrational number. So it's still going to be irrational. But here the options you can see, they don't say rational, irrational. So which option will you choose? And another way to think of this question is that if you take 1 by root 2, we can rationalize the denominator here, right? So we can say that this is going to be root 2 by, so I can multiply the numerator and denominator by root 2. So that's going to turn out to be root 2 by 2, right? And so we know that this guy is irrational and this guy is a rational number. So when we divide this, we are going to get a irrational number as our answer, right? It's going to work out to be, so whichever way you look, we are getting a irrational number. Okay, I see some people are experiencing buffering issue. I think it will soon stabilize. So just stay tuned, right? And try this question. So what is the option here? So the correct option is, because an irrational number is a non-terminating and non-recurring decimal, right? Irrational number, remember, they are non-terminating and non-recurring, means they do not have no repeating pattern. So excellent, guys. The right answer is going to be C. I see a lot of you are having option C. So that's very good. The correct answer is option C here. Excellent. Now guys, let's take a look at the next question. What is the HCF of 30 and 72, and use Euclid's division algorithm to find it? So I think many of you can find the HCF, which is defined as the highest common factor, right? So the HCF means highest common factor. So that's what we need to find. So what do you think is going to be the answer here? And we need to use Euclid's division algorithm to find it. So we need to show the steps of the algorithm here. All right, guys. So all of you go ahead and try this question. So what do you think is the answer of this question? The HCF of 30 and 72. So let me show you one trick to do this question. So before you, to show Euclid's division algorithm, you need to show all the steps. So first you can use the division method to find the HCF. So let's go ahead and do that. And I think most of you must be knowing this division method. So we'll take the larger number as the dividend, and we are going to divide this numbers. So the quotient here is going to be 2, right? And that's 60. So we get the remainder as 12. And again, we are going to divide. And this time the previous divisor will be the dividend here, right? So 12 by 30, right? So we are going to again get the quotient here as 2. So that's going to be 24. And if you subtract that, you're going to get 6 here. And now again, we divide by 12. So the quotient is 2 here, right? And this time, what is the remainder here, guys? The remainder is going to be 0, okay? So I think some of you can't see it, so let me move away, right? So can you see? The remainder is going to be 0 here. So here we've shown the steps of finding the HCF. So what is the HCF going to be? The last divisor here, right? For which the remainder was 0. So the HCF is going to be 6. Very good. I see a lot of you have got the correct answer. I see Gautam Devnath, Saraswati Gopal, Manisha Gupta. Excellent. Right? Vasudev, you've got the right answer. It's 6. But remember, we need to show Euclid's division algorithm. So if they ask you that, you need to show the steps there. And what is the trick of showing the steps? So we start with the larger number, which is 72. And we are going to write that. That's going to be equal to, right? So that is going to be equal to 30 into 2 here, right? And plus 12. So why are we writing this? Because remember Euclid's division lemma. So it's going to be of the form A equals, right, BQ, right? I should use another color for the Q here. So let me write that in yellow. So BQ plus R, right? Remember Euclid's division lemma, right? So we have this form A equal to BQ plus R. So we need to put these numbers in this form. So first we start with the larger number 72. Can you see that? And then we've written that's equal to B, which is the divisor here, 30. So we brought that here, and the quotient is 2 and the remainder is 12. There you can see, right? So that's the first step. So we've written 72 equals 30 into 2 plus 12. Now what is the next step going to be, guys? Right? So what is the next step? We're going to take this number here. So the 30 will come here, right? So 30 is equal to, right, this time. And so the 30 is going to become, so I'll use the green color here because it comes on the left side. So we're going to write 30 is equal to, right, 12. So that's again going to be in pink here. So that's 12 into 2, right? And plus our remainder was 6. Okay. So take a look at this, guys. So we are writing the step here. And this time we are going to take this number again here. So the number 12 now comes on this side. So we are going to get 12 equals, right? So this number 6 times 2, right? And the remainder this time is 0. So basically, can you see what we are doing? We are taking the number here 72 and expressing it in the BQ plus R form using our division that we've done here. So you can see it's 30 times 2 plus 12. Then we take this number 30, you just move it here to the left, and then you write the same thing for the next thing. So this is the algorithm, and algorithm means you need to show the steps. So 12 times 2 plus 6, right? And then the 12 comes here, 6 times 2 plus 0. And now can you see, since the remainder is 0, you know the HCF is going to be this last divisor, right? It's going to be 6. Very good. So we are using Euclid's division lemma, and the correct answer here is the number 6, and that's our right answer. And I've shown you the steps of Euclid's division algorithm. So if they ask you for the steps, you can't show this method. So of course, do that on the side, do the division, and you need to express it in these steps. So what we've shown here in these steps is known as Euclid's division algorithm, because it's a set of steps, right? And it's actually used in computer programming to find the HCF, right? So because it's a sequence of steps which gives you the HCF. Very good. So now let's take a look, guys, at the next question. The HCF of two numbers is 20 and their LCM is 420. If one of the numbers is 60, you need to find the other number. Okay, so guys, please try this. So this is our next question here. I want all of you to participate and try the questions. So very good. Please go ahead and try this question. So this is our next question, that what have we been given? The HCF of two numbers is given as 20, right? So we can say HCF is 20 and the LCM is given as 420. Right? And if one of the numbers, let's say we call that the number A, is 60, we need to find the other number. Let's call that B. So guys, how are you going to do this question? Please go ahead and try it out. Very good. I see a lot of answers here. Excellent. You guys are being interactive. And guys, if you're enjoying this session, do remember to hit the like button and share it out with your friends, right? So that they can attend this class or future live classes that we are having, right? So very good. I see a lot of you have got the correct answer. You're saying it's B. Now let's verify. So what is the method or the technique of doing this? So there's a very important formula that connects the numbers, the HCF and the LCM. And what is that important formula, guys? So the trick we use is A times, so if you multiply A and B, right, you're going to get, you can say A times B is equal to HCF into LCM. So we can say the product of the two numbers is equal to HCF times the LCM. So we can use this formula and it's very easy to find B. B is going to be equal to the HCF, which is 20, times the LCM 420, right? And that's going to be divided by the number 60. So if you guys go ahead and do this division, you're going to get the correct answer, which a lot of you have got. Superb. That's 140 is the right answer. Excellent, guys. Great going. So, and please remember this important formula. So this is our key formula in this question that you see here that I'm marking in this box. This is very useful formula that the product of two numbers is equal to their HCF, the highest common factor, and LCM, which you know is the lowest common multiple. Okay, superb, guys. Very good. Now let's go ahead and take a look at the next question. Write a rational number between root 2 and root 3. Okay, so as we discussed in the class earlier, right, root 2, you know, these guys are surds, so root 2 and root 3, and these are known as surds because they are the square root form, and you know that these are irrational numbers, right? So that's my hint to you. You know that these numbers are irrational, but we need to find a rational number between these two guys, root 2 and root 3. So how are you going to solve this question? Go ahead and try it out. Excellent. I'm seeing some answers here. I'm really happy to see everyone's interacting and trying it out. So go ahead and give this question a shot, guys. What do you think is the answer here? Very good. I see a lot of you are writing the right answer here. So let's take a look. What is the technique of doing this question? So the first thing is we need to find a rational number between square root of 2 and square root of 3, right? So we know that root 2 is something like 1.414, right? And what is root 3? The value of root 3 is something like 1.732, right? And you know that this keeps going on. This is just the approximate value because these are irrational numbers. They're non-terminating and non-recurring, right? They'll continue on and on, okay? But we need to find a rational number between these two. So if I write them here, so if we visualize it like this, so root 2, which is 1.414, and root 3, which is 1.732. So our mystery number that we need to find has to be between these two numbers. Okay, so let's take a look at our options. Since this is a multiple choice question, can it be 1.4? No, because root 2, it'll fall to the left side, right? Because root 2 is 1.414, so it's certainly not between these numbers. So this is not the correct option, right? And now if you look at the other options, the square root of 2.5 and root of 6, you know that these are of the form surds, and so these are again irrational numbers. But we are asked to find a rational number. So these are again not the correct answer here. So we are left with 1.6, right? And as you can see, 1.6 is definitely between root 2 and root 3, between 1.414 and 1.732. And why is 1.6 a rational number? Because you can express it as the form 16 by 10 as a fraction, right? P by Q. And if you want, you can simplify that also. It's going to be 8 by 5, right? So 1.6 is absolutely the right answer. Superb, guys. You guys got the right question, right answer, and very good. 1.6 is the correct answer for this question. Excellent. And I've shown you the technique of how you get that. Now let's take a look at the next question. So this is an interesting one. What is the sum of the exponents of prime factors in the prime factorization of 90? So we need to find the sum of the exponents here, guys. Okay. So sum of the exponents of the prime factors. and in the prime factorization of 90. So it's a really long question, right? So take a look, but it's not very difficult. So go ahead and try it. So I want all of you to try this question. And excellent, guys. I see a lot of answers here. It's amazing to see that. So please go ahead and try this question. And what do you think will be the answer here? So what is the trick of doing this question? So we have the number 90, right? We are given in this question, we've been given the number 90. And now let's take a look at what are the prime factors of 90. So what is it going to be, guys? So you know the prime factors are 2, right? And what else is there? So if you divide and see, the prime factors of 90 are going to work out to be 2 and into 3, right? And into 5 times 5, right? So you can see because 3 into 3 is 9 and times 10. So we've written down all the prime factors of 90. Not the factors, the prime factors, because 2, 3, 5, these are prime numbers, right? So that's the first thing we need to write. Now we need to do the sum of the exponents. So what we can express this as, this is 2 to the power 1. So the exponent is 1. This is 3 to the power 2 because exponent means the power, right? Power of these numbers. So that's 3 square times 5 to the power 1, right? So we need to find, very good. I see the right answer. You guys have got it. So if you look at the powers here, right? So 1, 2 and 1. These are the powers of the exponents of the prime factors. And the prime factors are, as you can see, 2, 3 and 5. So if you sum these powers, what are we going to get? So it's going to be 1 plus 2 plus 1. So the sum of the exponents of the prime factors is going to work out to be 4. Superb, guys. That is the correct answer here. So this is how you solve this question. Only the wording is a bit difficult, but actually you can see the question is very easy to solve. It's just a simple prime factorization. Don't look at the factors, only the prime factors, and solve it. Excellent. Now let's look at our next question. Here it is. If P and Q are prime numbers, then what is their LCM? Is it 1? Is it P by Q, P plus Q, or P times Q? Guys, what do you think is the answer here? Very good. I see a lot of you got the right answer for the previous question. Now go ahead and try this one. Okay. So if P and Q are prime numbers and we need to find their LCM. LCM, remember, lowest common multiple, right? So what do you guys think will be the answer here? Very good. So in case you get confused, you can always take an example. So here, let me show you a trick just to check your answer in the exam also. You can take an example. So let's take the example where, let's say the prime number P is 3, okay? And let's take the Q prime number as 5. So what is the lowest common multiple for 3 and 5, right? What is the lowest common multiple? So that's pretty easy. You guys know the lowest common multiple is going to be 3 times 5 here, right? So 3 times 5, and that's going to be work out to be 15, right? Pretty simple. And so what is it? You're basically multiplying the two numbers. So excellent. I see the right answer here. So if you look at the general form, so if the numbers are P and Q, it's going to be and they're prime numbers. So not for any numbers. So if P and Q are prime, their LCM is simply P times Q, right? Because their highest common factor is going to be 1. So you can think the LCM is the product, right? So that's another way of thinking. So what is the HCF of the two prime numbers? The HCF is going to work out to be 1, right? And again, if we apply the formula that we discussed today, right? Remember, so P times Q is going to be equal to the HCF, which is 1 times the LCM, right? Because P into Q is going to be that, and so the LCM is PQ. Super, pretty easy, right? Very good. Let's take a look at our next question. What is the HCF of the smallest composite and smallest prime number, right? So this basically means what is the HCF of the smallest composite number? So I can add that word there, right? And the smallest prime number. So what do you guys think is the answer of this question? So first you need to find what is the smallest composite number and what is the smallest prime number. So go ahead and try this out, guys. And guys, if you haven't hit the like button right now, and do subscribe to our channel Manocha Academy and hit the notification bell so that you get notified about all these live classes that we are having on physics, chemistry and maths, right? And you'll also get to know about our new video uploads. So very good. I see a lot of you are trying the right answer, trying the answers here. So let's take a look. What is the smallest composite number? So first we need to find that, right? So what is the composite number, guys? A number which is basically, composite number means it is not prime, right? So composite number is not a prime number. So what is the smallest composite number? So if we start from 1, we know 1 is neither prime nor composite. 2 is a prime number. 3 is a prime number. So the smallest composite number is actually going to be 4, right? Very good. And what is the smallest prime number, guys? So what is the smallest prime number? And the smallest prime number, it's not 1, because 1 is neither prime nor composite. It's going to be 2. So basically the question is simple, that you need to find the HCF of 4 and 2, right? The trick is only in the wording, where you need to know what is the smallest composite and smallest prime number. So what is the HCF of 2 and 4 going to be? So it's pretty simple. So what is the HCF of 2 and 4? Very simple, very good, guys. The HCF is going to be 2. And so the correct answer is B. Superb. I see a lot of you got it, right? So do remember this important thing. Composite numbers are those numbers which are not prime, and that's how you solve this question. Excellent, guys. Now let's take a look at our next question. The sum of two irrational numbers is an irrational number. Is this true or false? So this is an interesting question. So please go ahead and try it out. All right, I want all of you to try this question. Please give it a shot, guys. The sum of two irrational number, is it an irrational number? Is this true or false? Okay, so I see some of you are saying true, some of you are saying false. So what is the correct answer, right? So again, you can think of some examples, right? So if you think of things like, so let's say if you're thinking of root 2 plus root 3, right? It looks like, because root 2 is definitely irrational and root 3 is irrational. And if we add these, we are getting an irrational number. So it looks like the answer is true, but can we find a case where sum of two irrational numbers can give us a rational number? That's what you need to think, right? So this one looks fine, or if you do root 2 plus root 5, right? It looks simple. But let me show you an example where is it possible? What do you guys think? Let's try it out. So if we do, let's say root 3, and we add to that minus root 3, right? So if we take, because we know that root 3 is an irrational number, but we add the negative of root 3, right? Which is also an irrational number. So if you add these two guys, what are you going to get? You're going to get 0. And 0 is definitely rational. Okay. So can you see that there is some cases for this case, or if you take root 2 plus of minus root 2, you're going to get 0, right? So the right answer is false. Very good. I see a lot of you got it. Or if you were thinking true, no problem. Just take a look, think of this case, and this is a nice simple case where you can clearly prove that this statement is false. It's not valid for all the summations, so it's not a true statement. Excellent. Now guys, take a look at this question. Is 7 times 11 times 13 plus 13 a prime number? So is this true or false? What do you think? So go ahead and try this question, guys. So this is an interesting question. Is 7 times 11 times 13 plus 13, is it a prime number? Okay. So I see a lot of you are saying, no, it's not a prime number. It's false. So what is the right answer here? How do we work it out? Let me write down this number first. So we've got 7 times 11 times 13 plus 13, right? That's our number here. Now, is this a prime number? One interesting thing you can see, it's all having prime numbers, 7, 11, 13, and then you're adding a prime number to it. So is it going to be prime or not? How do we prove this? So one way is that you sit and multiply these numbers out and add it, right? But that's the lengthy way. right? Let me show you a simple trick of how to solve this question. So what do you do here? You just take 13 common, right? So if you take 13 common, you're going to get 7 times 11, right? And plus 1 here, right? So, and we don't even need to work it out. We're not going to work it out because you can see that there's this fact. So you have the 13 multiple in front. So clearly this number can be divided by 13 because this will cancel. So definitely this number is not a prime number. So the number is not prime. It's a composite number. It is not a prime number because as you can see, we proved that it is, divisible by 13. So it's not a prime number here, right guys? So see, you don't have to calculate the number. So we just took out the common factor 13 and it's clearly divisible by 13. So very good. I see a lot of you have got the correct answer. It's not a prime number. So excellent. The right answer is false. You guys rock. Superb. Now let's take a look at this question. What is the least number which is divisible by natural numbers from 1 to 10? So both inclusive, right? So natural numbers from 1 to 10, you know, are 1, 2, 3, 4, right? Right up to 10. And we're going to include both 1 and 10. And guys, you can see that I've not given any options here because I want you to try this question yourself and do write your answer in the comments below. I look forward to reading your answers and I promise to reply to them as soon as possible. So take a look at this interesting question. What is the least number which is divisible by all the natural numbers from 1 to 10, both inclusive? Okay, and I want everybody to try this question and write your answer in the comments below. So this is your homework question. I know some of you are answering it here. That's very good, but I'm not going to tell is it right or wrong because I want everyone to try themselves. And guys, if you haven't checked out these videos on our channel, Manocha Academy, do watch them. We have these real number videos where this one is especially relevant for class 10. Class 9 can also use it. And this one is more relevant for class 9, right? But again, if you're in class 9 or 10, I think these videos will help you. So do check it out where we have real numbers and the number system. And I've made the concepts really simple and easy for you. So I'm sure they'll be very helpful for you. And guys, do check out our channel, the website manochaacademy.com. I put the links below. And as I said, we'll be launching the chemistry and maths courses also soon. We have the physics courses for you and big discounts are available. So do check them out. And if you haven't hit the subscribe button for our YouTube channel, hit it right now and do share it out to your friends so that we have more people joining the Manocha Academy family. And excellent guys, I was really happy to see the interaction where a lot of you were trying the questions and it's really amazing to see that. And thanks a lot for your support. So do check out these videos on real numbers and do remember to try this homework question that I've given you. Okay guys, so this is the homework question and I want you to write the answer in the comments below, and I'll be taking more live classes on physics, chemistry, maths. So we'll have another class maybe on this real number topic where I'm going to bring more interesting questions. So I want you guys to be ready for that quiz also. So go ahead and watch these videos, revise and read your textbook. Make maximum use of this time. I know all of you are under lockdown, so hope everybody's safe and fine, but use this as your study time and do check out these videos. I think they'll help you a lot, and do read your book. So awesome guys, it was a great session with all of you, and please do check out our website as well and share it with your friends. All right guys, take care and hope you enjoyed the session. Remember to hit the like button right now and share it out with your friends and family. Thanks a lot guys. Bye. Take care.